Okay, in this afternoon session, as I said this morning, I will explain about the final three parts final three parts related to differentials, but concavity and curve sketching, then intermediate forms, and Lupita's rule. I assume that this Lupita's rule, you've heard this name in your high school, and I think that you will like it. And then finally about applied optimization related to the differentials. And then if time let me, I will add explanation about antiderivatives and sigma notation in preparation for next week's material. So, concavity and curve sketching. Yeah. Concavity and curve sketching. What does it mean by concavity? Before I open the slide, what is concavity in this case? What is concavity in bahasa?
Yes, sir.
Yeah. What is concavity in bahasa Indonesia? Anyone knows?
No, I don't know.
Cekungan, sir.
Yes, correct. Yeah, concavity is kecekungan. Yeah. So what we are learning about today is about concavity, or in bahasa Indonesia is kecekungan. So, what is the definition of concavity that we will use? Is okay, the graph of a differentiable function y equals to fx is concave up. So this is concave up. Looks like this, yeah, cekung ke atas on an open interval I if f prime is increasing on I. Jadi cekung ke atas pada interval I kalau turunannya itu adalah fungsi naik pada interval tersebut. And then concave down on the open interval I if f prime is decreasing. So concave down is like this. Do I have something that I can play with? No. Okay. Concave down is something like this. So you have a maximum. Concave up you have a minimum, but concave down you have a maximum. Ya, cekung ke bawah on an open interval if f prime is decreasing. Ya. Jadi di sini cekung ke atas kalau turunannya adalah fungsi naik, cekung ke bawah kalau turunannya adalah fungsi turun. How to check the concavity? Okay, in this case we can use the second derivative test. So basically, we can find the differential of y, the second derivative. So the derivative of f prime. So we have f double prime here. If f double prime is positive, then the graph is concave up. If f double prime is negative, the graph is concave down. Jadi di sini jelas ya. Kalau tadi yang kita bahas adalah turunan pertama. Dengan turunan pertama kita bisa menentukan apakah fungsi itu fungsi naik atau fungsi turun ya. In our morning session, we have learned that from the first derivative, we can conclude whether the function is increasing or decreasing. So, if we want to find whether the derivative is increasing or decreasing, we need to derivate it again. We need to differentiate it again. Ya. Jadi di sini yang mau kita cari apakah turunan pertamanya yang naik atau turun. Dalam hal ini berarti kita harus cari turunan pertama dari turunan pertama, ya. Berarti turunan kedua. Ya, turunan dari turunan pertama adalah turunan kedua. That's it. For example, The curve of y equals x cubed is concave down on minus infinity to 0 and concave up on 0 to positive infinity. Yeah. Why? Because the second derivative of x cubed is 6x. Yeah. So in this case, we know that as long as the x is negative, the second derivative is negative, and as long as the x is positive, the second derivative is also positive. Turunan kedua dari x pangkat 3 adalah 6x ya. Nanti kalian bisa cari sendiri. Di sini kita tahu bahwa karena 6x ini negatif, kalau x-nya negatif, berarti di interval ini minus tak hingga sampai 0 dia cekung ke atas. Di interval 0 sampai positif tak hingga dia cekung kebalik ya. Yang tadi cekung ke bawah, kemudian cekung ke atas. Let me show you the example. Using plots. And f of x is x power 3. In this case, we try to plot f x from minus 3 to 3. Like this. Oh no, this is not correct. From minus 3 to 3. So here we have the plot. Yeah, this is the plot of x cube. Ini plot dari x pangkat 3, and we see that on the left side of this, so on negative x, x tabel is x. So here is x, yeah. X is this horizontal axis, and y is the vertical axis. So we see that on negative x, the curve is concave down, and in positive x, the curve is concave up. Ya. Jadi di sini kelihatan bahwa x-nya, kalau x-nya negatif, dia kurvanya cekung ke bawah ya, cekung ke bawah. Ini namanya cekung ke bawah. Kemudian ketika x-nya positif, dia cekung ke atas. Any question?
No, sir. It's clear.
Okay. And the curve of y equals to x squared is concave up on the whole interval for all x, because the second derivative is 2. X kuadrat itu tercekung ke atas karena turunan keduanya adalah 2, yang mana ini selalu positif. So if we plot x squared, the plot looks like this. You see that the curve is concave up. Ya. Jadi kurvanya adalah cekung ke atas. Now, if we have the another question, determine the concavity of x equals to 3 plus sine x on 0 to 2 pi. In this case, we have that the first derivative is cosine of x, and the second derivative is minus sine of x. So in this case, we know that minus sine of x is positive. Sorry, minus sine of x is negative from 0 to pi. So the function is concave down on 0 to pi, and then is positive from pi to 2 pi. In this case, we have that from pi to 2 pi, the curve is concave up. So let's see this plot. Plus sine of x, and f is from 0 to 2 times and let me add a plot. Let me add another plot. Now the plot is from not here, down here. Is from pi to and here is pi comma 0 to pi comma sorry. I hope that is, yeah, you see here we have pi here, right? So we see that the curve is concave down from 0 to pi and concave up from pi to 2 pi. Jadi di sini kita bisa lihat bahwa garis merah ini menunjukkan titik P, ya. Dan di sini kita lihat bahwa dari 0 sampai P kurvanya cekung ke bawah, dari P sampai 2P kurvanya cekung ke atas. Is it clear?
Yes,
Any question?
Berarti kalau dia negatif, dia cekung ke bawah, kalau positif cekung ke atas ya, Sir?
Yes, yes. This is according to this, yeah. Yeah, if the second derivative is negative, then concave down. If the second derivative is positive, then concave up. Yeah.
Okay, Sir. Thank you, Sir.
Now, there is also a definition that is called a point of inflection. Point of inflection. So, what is a point of inflection? A point of inflection is a point where the graph of a function has a tangent line and where the concavity change. Ya, point of inflection itu adalah titik balik, ya, titik perubahan kecekungan pada dasarnya. Ya. So there is a note here, at the point of inflection, either the second derivative is 0 or the second derivative fails to exist. Ya. Jadi di titik baliknya, ya, pergantian seperti contoh yang ini, like this example. At this point, pi, 3, this pi, 3 is the point of inflection. Why? Because the concavity changed from concave down to concave up. Di sini adalah titik balik dari kecekungannya ya, P, 3 ini. Karena dia di titik itulah ada perubahan dari cekung ke bawah ke cekung ke atasnya. Nah, di titik ini ya, at this point, the derivative, the second derivative is 0 or fails to exist. I mean, or undefined. Di titik inflection ini, turunan keduanya itu kalau tidak 0 ya berarti tidak terdefinisi. So, for example, like this picture, like this equation, a particle is moving along a horizontal coordinate line, positive to the right, with a position function like this. We are asked to find the velocity and acceleration and describe the motion of the particle. Jadi di sini persamaan posisinya adalah ST sama dengan ini, ya, di mana T-nya positif, T-nya tidak negatif. Kita diminta untuk mencari kecepatan dan percepatan, kemudian mendeskripsikan bagaimana pergerakan si partikelnya. Dan here we have that the velocity is the first derivative, which is s prime, which is 6t squared minus 28t plus 22. Or we can factorize it to be like this, 2 times t minus 1 times 3t minus 11. And we see that the acceleration is the second derivative of position or the first derivative of velocity. Yeah, so a is equal to f prime or equal to s double prime, which is 12t minus 28, or we can factorize it to be like this, 4 times 3t minus 2. So in this case, we see that when the function is increasing, the particle is moving to the right, and when the function is decreasing, the particle moving to the left. The solution will look like this. Okay, so in the interval from 0 to 1, the sign of the velocity, sign of s prime is positive, which means that s is an increasing function from 0 to 1. In this case, the particle motion, it moves to the right. And then from 1 to 11 over 3, we have that sign of the velocity is negative. So in this case, the function moves to the left because the behavior is decreasing. And if t is greater than 11 over 3, we have that the particle move to the right again. Jadi di sini kita bisa lihat bahwa dari 0 sampai 1 kecepatannya tandanya positif, berarti dia maju ya, maju ke kanan. Kemudian dari 1 sampai 11/3 kecepatannya negatif ya. Di dunia matematik, fisika, apalagi di teknik ya, kecepatan negatif itu artinya mundur. Jadi di sini bergeraknya, kalau yang tadi majunya ke kanan berarti mundur ke kiri. Dan positif maju ke kanan lagi. And for the concavity, we check the acceleration. So here we find that from 0 to 7.7 over 3, the graph is concave down, and from 7 over 3 to infinity, the function is concave up. Let's see the picture here. So S of t is equal to 2 times t cubed minus 14 times t squared plus 22 times t minus 5. And let's plot it from 0 to, let's say, 10. No, not F, S. It's too big. To 10. And let's plot it up to 5. You see the position. First it go up, so it go to the right, and then down, go to the left, and then up again. And we see here that at 7.7/3, then let's plot the point of inflection. And S of 7/3. See that we find the point of inflection here at 7/3. So we see that here this is concave down until the red dashed line, and then it concave up. Yeah. Any question?
Sir,
Yeah.
before slide-nya sebelumnya lagi. No. That's yang dihitungan, sir. Tapi yang sebelumnya, yang slide pertama hitungannya, sir.
Ini?
Yeah, that one. Wait, sir. Sir, maybe this. Mungkin ini pertanyaan agak aneh, sir. Cuma yang di solution, sir, pas the velocity is Vt turunan ST sama dengan 6T kuadrat kurang 28T tambah 22 sama dengan, nah itu yang di sebelah kanannya, sir, dari mana ya, sir?
So, okay, let me just take this one, okay? So 6t squared minus 28t plus 22 is equal to 2 times 3t squared minus 14t plus 11. And that's why this is, we factorize this. So we have 2 times t minus 1 times 3t minus 11. Is it clear?
Oh, I see, sir. Oh, ini, yeah, okay. Thank you, sir.
Just the normal factorization. Yeah. Okay, any more question? Any more question?
Sir, terus kalau yang di bawahnya, sir, itu gimana, sir? Kan dia dari 2 dalam kurung T kurang 1, 3T kurang 11, terus dia, how we know dia jadi 4, 3T kurang 7 itu, sir?
First, we differentiate this guy.
Yeah, I know the difference.
We differentiate it, we get 12t minus 28. Then we divide everything by 4, so we have 4 times 3t minus 7.
Oh, berarti habis turunkan dulu ya, sir, baru bikin itunya.
Yeah.
Kirain ikut dari atasnya, sir. Okay.
Nah.
Yes, sir.
Any more question? No? then yeah, this is basically the second derivative test. Okay, this is basically another second derivative test, because we now know about monotonicity, whether the function is increasing or decreasing, and then we have a concavity. From this information, we can build up this second derivative test for local extrema. So suppose that we have f function, and the second derivative is continuous. Then if at x equal to c, the first derivative is 0 and the second derivative is negative, then f has local maximum. And if the first derivative is 0 and second derivative is positive, it has local minimum. But if both are 0, then the test fails. Jadi kita bisa menggunakan turunan kedua untuk menguji apakah dia maksimum atau minimum. Caranya, cari turunan pertamanya sama dengan 0, ya. Kalau turunan pertamanya sama dengan 0, kita temukan titiknya, kemudian kita masukkan ke turunan kedua. Kalau turunan keduanya negatif, maka kita punya lokal maksimum. Kalau turunan keduanya positif, kita punya lokal minimum. Tapi kalau keturunan keduanya sama dengan 0, maka tidak bisa mengambil kesimpulan apa-apa, ya. Ujinya gagal. Bisa jadi ada lokal maksimum, ada lokal minimum, tapi bisa jadi juga tidak ada. Ya, seperti itu. This is how well, we can use this later, but now I want to show you how to sketch a graph where we know the monotonicity and the concavity. Yeah. Okay, we want to sketch the graph of this function. Here we have that f prime of x is 4x power 3 minus 12x squared. That's all. Yeah. Or we can also write it like this: x squared, 4x squared times x minus 3. And then the second derivative is 12x squared minus 24x, or we can write it like this: 12x times x minus 2. So from this, we have that, okay, this is f prime, x for f prime. We have that at 0 and 3. So from this one, we want to find the extremum. Yeah. The extremum is at 0 or 3. Then in this case, we can make this wall. 0 is power 2, 3 is power 1. Then if we put 1 inside, we have negative, and here is also negative, and on the right side is positive. Then from here we have that f increasing on 3 to positive infinity, and f is decreasing on let's say minus infinity to 0 and from 0 to 3. Yeah, we have the first clue, and for the second clue, here is x, and this is for f double prime. We have 0 and 2 from here, from 12x x minus 2, and we build the wall, and this wall, all of them with the power 1. If we put, let's say, 1, then we have negative. For the rest, we have positive. So from this one, we have that f concave down on 0 to 2, and f concave up on minus infinity to 0, or from 2 to positive infinity. So in this case, we can actually try to plot it. Yeah. Well, here we have that the extremum value is 0 and 3. Ya. Kita tahu nilai not extreme value. We know that the critical values are 0 and 3. Jadi kita tahu titik kritisnya adalah 0 dan 3. So in this case, we want to find f0 is what is f0? F0 is 10. F0 is 10, and f2 is from the second derivative. We know that f2 f double prime 2 is 0. Ya. Jadi kita tahu bahwa turunan kedua di titik 2 adalah 0. So we have the point of inflection. But here what we want to find is the value of the function. At 2 we have 2 power 4 minus 4 times 2 power 3 plus 10, which is 16 minus 32 plus 10, which is 6.
Bukan minus 6, sir.
Oh, sorry, minus 6. Yeah, that's correct. Thank you. And f3 is here is the, so we have minimum, then we have decreasing and then increasing, then we have minimum value there, local minima, which is 3 power 4 minus 4 times 3 power 3 plus 10. So 3 power 4 is 81 minus 4 times 3 power 3. 4 times 27 is
108.
108. Yes. Plus 10. So in this case we have minus
17.
Okay, now we have all the points needed. So we can draw it like this. here is x and y. We have at point 0, the value of the function is 10. And at point 2, the function value is 6. Here is 2. And at 3, the function value is minus 17. So this is minus 6. And here is 10. And we have minus 17. Maybe here. Minus 17. So what we have is that, okay, from 0 to 2 is concave down, and okay, from minus infinity to 0 is decreasing and concave up. Yeah, decreasing and concave up. So basically what we have is minus infinity to 0, something like, let's plot it with the blue color. It should be something like this, concave up. And then from 0 to 2 is concave down. So we have a point of inflection here and concave down like this. And then after 2, it is concave up, but okay, still decreasing until 3 and then increasing after that. So what we will have is something like this. Concave up, then we have something like this. So here we have the rough sketch of this function. Jadi ini kira-kira cara menggambar kurva kalau kita tidak punya bantuan program seperti yang saya lakukan biasanya. What we do is first we find the extreme value, yeah, and the critical values, and then the extreme values, and then after that find the increasing or decreasing intervals, and then determine concavity, and then after that we can sketch the plot. Yeah. Gitu. Yeah. Any question? Cara gambar kurva gini ya sebenarnya ya. Pertama kita cari turunan pertama, turunan kedua. Dari turunan pertama kita dapat titik ekstrimnya. Kemudian kita bisa tentukan apakah dia turun atau naik ya. And then from the second derivative dari turunan kedua, we can find the concavity. Ya. Kita bisa menemukan kecekungannya. So from here, from this information, we can roughly sketch the function. Dari informasi-informasi itu tidak susah untuk menggambarkan fungsinya. Any question? No? Is it clear?
Ya, sir. Mungkin contoh lagi sih, sir.
Yeah. Well, there is another example. This one. The step is the same, yeah. We find f prime. F prime of x is 2x plus 1 times 1 plus x squared minus x plus 1 squared times 2x over 1 plus x squared squared. So in this case we have 2 times x plus 1 times 1 plus x squared minus x plus 1 times x. So over 1 plus x squared. So we have 2 times x plus 1 times x squared minus x squared is 0. So we have 1 minus x over 1 plus x squared squared. So in this case, this is equal to 0 if x equal to minus 1 or x equal to 1. And then f double prime of x is, okay, so that we can easily differentiate it. We try to write it like this: 2 times 1 minus x squared over 1 plus x squared squared. Mereka sama ya, karena x plus 1 kali 1 min x adalah 1 min x kuadrat. So now we have minus 4x times 1 plus x squared squared minus 2 times 1 minus x squared times 4x 1 plus x squared. Divided by 1 plus x squared power 4. So in this case we have that f double prime is equal to, okay, minus 4x minus 4x times 1 plus x squared multiplied by 1 plus x squared minus 1 plus x squared here, 4x is out. So we have minus, not minus, plus 2 times 1 minus x squared, I think. Yeah, it should be plus, divided by 1 plus x squared power 4. So in this case we will have minus 4x 1 plus x squared multiplied by 1 plus 2, so it is 3 x squared minus 2x squared, so minus x squared divided by 1 plus x squared power 4, which is equal to minus 4x 1 plus x squared square root of 3 minus x square root of 3 plus x divided by 1 plus x squared power 4. So this is equal to 0 if x equal to 0 or x equal to square root of 3 or x equals to minus square root of 3. Yeah. Up to this point, any question?
Sir.
Ya.
Atas lagi, Sir. Cuma pertanyaan dasar sih, Sir. Jadi saya masih bingung, Sir. Kalau untuk yang pembilangnya itu yang x tambah 1 pangkat 2 itu, Sir. Kalau diturunin itu, dia jadi gimana ya, Sir? Kan hasilnya itu tuh, Sir udah tulis semua masih.
Pakai aturan rantai.
Aturan rantai itu berarti yang bentar.
Let me write it here, okay? Y equals to x plus 1 squared. Then let u to be equal to x plus 1, and y is equal to u squared, right? So in this case, dy dx is equal to dy du times du dx, which is 2u times du dx is 1, so we have 2 times x plus 1. Ya. Kita pakai aturan rantai ini ya. Jadi kita misalkan u-nya adalah x plus 1, sehingga kita punya y sama dengan y sama dengan u kuadrat. Kemudian untuk menurunkan y terhadap x, maka kita punya turunan y terhadap u dikalikan dengan turunan u terhadap x. Sehingga kita punya turunan y terhadap u adalah 2u, turunan u terhadap x adalah 1. Is it clear?
Oke, Sir. Mengerti, Sir. Thank you, Sir.
Yeah. Any other question? Any other question? No?
Sir.
Ya?
Ini caranya emang harus kayak gini ya?
Yes.
Apakah nggak bisa dikompakin lagi gitu?
No. Why? Because we have, for this case, we have division, we have a quotient. Ya. Kita punya pembagian. Untuk turunannya, ya, for the derivative, we have to use the quotient rule. Jadi untuk turunannya kita harus pakai aturan pembagian, ya. And let me tell you this, in chemical engineering, for example, in thermodynamics, you will find this kind of derivative a lot.
Okay. So
Yeah.
For this we have to use dua aturan ya kan?
Yeah.
Okay.
The chain rule and the quotient rule at the same time. Yes.
Thank you, sir.
Yeah. Okay. Now we have, okay, from the first derivative, let me use blue color. This is x. Yeah. We have minus 1, 0, and 1, and we build the wall, and the power are 1. So in this case, we can build, we can put 0 in here. If we take 0, then we have the value to be positive. 1 minus 0 squared is positive. And then the rest are negative. So in this case, we have that F is increasing on minus 1 to 1 and decreasing on minus infinity to minus 1 or from 1 to infinity. And from the second derivative, we build again the lines x. We have 0 and minus square root of 3 and plus square root of 3, and we built the wall on all of them. We have the power are 1 1 1, so the power are 1. So in this case we can try to put 1, yeah, because 1 is somewhere here. There is 1. So let's try to put 1 to substitute 1 to this equation. We have to this equation, it is easier. Minus 4 times 1 is minus, times positive still minus, times positive still minus, and the denominator is minus. So here is minus, then the rest is positive, minus, positive, like this. So we have that concave up. Concave up, concave down, here concave up again, and on the left we have concave down. So now we finally can try to draw the picture, but before that we have to find the value for f0, f minus 1. Okay. f0 is 0 plus 1 squared over 1 plus 0 squared. So in this case we have 1. F of minus 1 is f minus 1. Here we have local minima, and f plus 1 we have local maximum. So in minus 1 we have minus 1 plus 0 squared over 1 plus minus 1 squared. Here is, sorry, this is not 0. Minus 1 plus 1, because we have, yeah, minus 1 plus 1 is 0, then in this case we have 0, and f of 1 is equal to 1 plus 1 squared over 1 plus 1 squared. This we have 2 over 2, which is equal to 1, and then f of minus square root of 3 is equal to minus square root of 3 plus 1 squared over 1 plus square root of 3 minus squared. So in this case we have, this is quite challenging. 4 minus 2 square root of 3 over 4, or we have 1 minus half square root of 3, and at f positive square root of 3 is square root of 3 plus 1 squared over 1 plus square root of 3 squared. So in this case we have 4 plus 2 square root of 3 over 4, which is 1 plus half of square root of 3. So now we are ready to build to draw the picture. here is x, here is y, and we have f at f of 0 is 1. Here is 1. F of minus 1 is 0 here. F of 1 is 1. And f of minus 3, minus square root of 3 is 1 minus half of square root of 3. It should be around here. Sorry, minus square root of 3 is here. So the value is 1 minus half of square root of 3. So this is minus square root of 3, and at this point is 1 minus square root of 3 over 2. And then at positive square root of 3, we have somewhere here. This is 1 plus square root of 3 over 2. Then now we can draw it. Yeah. Concave up, concave down up to minus square root of 3, and decreasing. Concave down and decreasing, so it's basically, it should look like this. Let me use the red lines. So it should look like this. Concave down, and here is the point of inflection, and concave up, and at minus 1. At minus 1 we have minimum. So concave up, that now it looks like this. Concave up to that point, up to 0, and then concave down up to minus 3. Did I make a mistake? No. Concave up until 0, and then concave down until square root of 3. How to build it? But we have increasing up to 1. Sorry, F0. What is F0? 0 plus 1 squared is 1. 1 plus 0 squared is 1. So this is correct. This is tricky. Maybe I made a mistake somewhere over there. I don't know. Yeah. 2x1, okay, minus x plus 1 squared times 2x. Okay, this is correct. So here I collect the 2x plus 1, where we have 1 plus x squared minus x plus 1 times x. So here we have 2x plus 1, and then x squared minus x squared is 0, and 1 minus x. This is correct. Up to this point, it should be correct. For the second derivative is, okay, 2 times minus 2 is minus 4x times 1 plus x squared minus 2 times 1 minus x squared multiplied by the derivative of the bottom guy is 2 times 2x, so 4x times, yeah, that is correct. And then when I collect it, we have minus 4x we take out, minus 4x, and then 1 plus x squared we take out, then we have 1 plus x squared plus 2 times, yeah, this should be correct, I think. So 1 plus 2 is 3. Yeah, this should be correct. Let me just plot it with the machine. F of x is equal to squared, so x plus 1 squared over 1 plus x squared. Just plot f from minus 2 to, sorry, from minus 3 to 3. Here is x and f, sorry, y. The plot should look like this. Oh, maybe I made a mistake. At x equal to 1. Okay, sorry, I made a mistake in it. This is not 2, but 4. So that's why. This is 4 over 2, so it should be equal to 2. Then the value of the function should be somewhere here. This is 2, yeah. Sorry, it was my mistake. And now we can continue. It should be like this. Oh yeah, now it concave up again. Yeah. Any question?
So, sir, the first is it concave down and then it concave up, right?
Yeah.
Okay.
You can see here, it is the concavity. It is divided like this: concave down, concave up, and then concave down again, and then at this point of inflection, it is concave up.
Sir, bisa turunin dikit sir, soalnya ketutupan sir.
Apanya?
Grafiknya.
Here?
Okay, thank you sir. Berarti memang sesuai sama kayak yang di sistem kan sir, cuma emang tadi sir agak ragu ya, atau?
Enggak, no. I was making a mistake here.
Oh, there. Yeah, I see.
Where it should be 2. Sorry, that was basically a silly mistake.
Okay, thank you, sir.
Yeah. So, any more question? No? So if no more question, I can continue with. You can try to learn about this later by yourself because it is not that hard. But I want to continue with this guy. Yeah. Okay. Now we learn about indeterminate forms and Lupita's rule. What is basically indeterminate forms? Indeterminate form is the limit of this. Okay. So if you have 0 over 0, or infinity over infinity, or infinity times 0, or infinity minus infinity, or 0 power 0, or 1 power infinity, then we have that the limit is in the indeterminate form ya. Jadi kalau kita punya bentuk-bentuk kayak gini ya, kita tidak bisa mencari nilai limitnya karena dia tidak bisa ditentukan. But don't worry ya, we have tricks that is called Lupita's rule ya. Well, there is an S missing here. This is called Lupita's rule. Basically, what Lupita's rule says is that if we have a limit of quotient like this, f over g, then it is equal to a limit of f prime over g prime if f over g is in the indeterminate form ya. Jadi aturan L'Hopital ini mengatakan bahwa oke, kalau kita punya bentuk, kalau kita langsung substitusikan ternyata nilainya 0 per 0 atau tak hingga per tak hingga, maka kita bisa menggunakan aturan L'Hopital dengan mencari turunan pembilang dibagi turunan penyebut ya. Here we don't use quotient rule, we just differentiate both numerator and denominator by themselves ya. Jadi kita turunkan satu-satu ya, bukan pakai aturan pembagian. I assume that you have learned about this rule in your high school, right? Sudah pernah belajar ini di sekolah?
No, sir.
Ooh. Well, maybe the curriculum change.
Yeah.
Well, about maybe 13 to 14 years ago, it is still there in the curriculum. Then okay, then okay, that's fine. But now you know this, right?
Yes, sir.
For example, okay, the first case is if we substitute 0 to 3x minus sin x, what do we have? 3 times 0 is 0 minus sin of 0 is 0. So 0 and over divided by x, which is 0. So in this case, we have indeterminate form, which is 0 over 0, right? Then this theorem says that, okay, to find the limit, we can differentiate both numerator and the denominator. Ya. Jadi untuk cari limitnya, kita bisa turunkan pembilangnya, kita turunkan sendiri, penyebutnya kita turunkan sendiri, bukan pakai aturan pembagian. Ya. So that in this case we have, okay, the numerator we have derivative of 3x with respect to x is 3, and derivative of sin x with respect to x is cosine x. Yeah, so we have 3 minus cosine x. And for the denominator, ya, untuk penyebutnya kita punya, we have a derivative of x is 1. So in this case, we can directly substitute x equal to 0, which we have 3 minus 1, which is equal to 2. Same thing happened with the B case. If we substitute 0, we have 0 over 0. So in this case, we differentiate the numerator and the denominator. Kita turunkan pembilang sendiri, penyebutnya sendiri. The numerator becomes 1 over 2 square root of 1 plus x, and the denominator becomes 1. So we can directly substitute x here, which is the limit is half. So let me show you this. For A, basically from our trick before, from our previous trick, we have limit x goes to 0, 3x minus sin x over x is equal to limit x goes to 0, 3 minus sin x over x, which is 3 minus limit x goes to 0 sine x over x, which is 3 minus 1, which is 2. Yeah, you see here we have the same limit. And for B, we have limit x goes to 0, square root of 1 plus x minus 1 over x. We multiply both numerator and the denominator by 1 square root of 1 plus x plus 1 over square root of 1 plus x plus 1. In this case, we have limit x goes to 0 of 1 plus x minus 1 over x times square root of 1 plus x plus 1, which is equal to limit x goes to 0, x over x square root of 1 plus x plus 1, which is now we have limit x goes to 0 of 1 over square root of 1 plus x plus 1, which is 1 over 2. Half. You see that we get the same value, right? The same thing with this C and D. Yeah. So for C, we try to differentiate both numerator and denominator. Because if we substitute 0 here, we have 0 over 0. So we differentiate. Turns out that if we substitute here 0, then we still have 0 over 0. Then we use L'Hopital's rule again to differentiate again. Then we compute the value. Ya. Jadi dengan aturan L'Hopital ya, karena kita punya 0 per 0, kita pakai aturan L'Hopital, kita cari turunan yang pembilang, dibagi turunan di penyebut. Kemudian ternyata kalau sudah disubstitusikan masih 0 per 0, kita turunkan lagi pembilang dan penyebut masing-masing, baru kita bisa substitusikan. Ya. Also with D, the same thing happen. Ya. Any question? Any question? No? Is it clear?
Clear, sir.
Okay, but we have to be careful. Yeah, see this slide title is "Be careful when applying L'Hopital's rule." Yeah. So what we need to do, when we can apply L'Hopital's rule is only when the indeterminate form happens. Ya. Jadi kita cuma bisa menggunakan aturan L'Hopital kalau kita menemukan indeterminate form. Ya. If we find this 0 over 0 or infinity over infinity or those other indeterminate forms, then we can use L'Hopital's rule. You see here, if we substitute 0, then in the numerator we have 1 minus 1 which is 0, and the denominator is also 0. So we have 0 over 0, which is not allowed. Ya, jadi di sini contoh ini ya, kita punya, kalau kita substitusikan langsung, kita punya 0 per 0. Maka kita punya indeterminate form, maka kita then we can apply Lupita's rule. But after we differentiate, we get sin x over 1 plus 2x, which is not 0 over 0. Yeah. In this case, if we put 0, if we substitute 0 to sin x, we have 0, and the denominator is 1 plus 0, which is 1. So we have 0 over 1, not 0 over 0. Di sini kita punya 0, kita punya 0 per 1 ya, bukan 0 per 0. Dan, well, it's true that in this case it is very tempting to try to apply Lupita's rule again. Ya. Jadi di sini, wah, kayaknya kayaknya masih perlu apply aturan Lupita lagi nih, gitu. Karena kelihatannya sih masih perlu. But if we apply Lupita's rule again, it will result in this, yeah, cosine x over 2, which makes the limit becomes 1 over 2. But in this case, this is not the correct limit. Yeah. So there's the note here. Lupita's rule can be applied only to limits that give indeterminate forms. Ya. Jadi aturan L'Hopital itu cuma bisa digunakan kalau kita menemukan bentuk indeterminate, ya, bentuk yang tidak ada limitnya. 0 per 0, infinity per infinity, or the rest. Yeah. Any question? No? Then, next is, L'Hopital's rule also applies to one-sided limit. Yeah. If we have one-sided limit like this, we can use L'Hopital's rule. The same, so this is easy. And this is the example. This is the next example for infinity over infinity, ya. Jadi di sini contoh untuk tak hingga per tak hingga. And in this case, we can also apply L'Hopital's rule. We can apply L'Hopital's rule for which, we get the A is 1, B is 0, yeah, because of the L'Hopital's rule. Derivative of ln x is 1 over x, and derivative of 2 times square root of x is 1 over square root of x. And we have 0. And also for C, we use L'Hopital's rule. In this case, we obtain this e power x over 2, which means that the limit is infinity. Yeah. For this example, any question? Any question? No? Is it clear?
Yes, sir.
So let me ask you a question. Do you like this L'Hopital's rule?
Well, sir, to be honest, it might be tricky, and yeah, seems it make me dizzy.
Why?
It has too much
information.
Maybe I will watch the record again, and maybe I will more understand.
Yeah. Okay. Let me restate what does it mean by L'Hopital's rule, ya. In bahasa Indonesia full. Aturan L'Hopital itu adalah aturan untuk mencari nilai limit. Ya. Kalau kita punya pembagian, tapi kalau kita langsung substitusikan, ternyata nilainya 0/0 atau tak hingga per tak hingga, maka kita bisa melakukan ini, ya, aturan Lupita. Saya tidak tahu mengapa di kurikulum sekolah sekarang tidak ada, ya, tapi sekitar 13-14 tahun yang lalu itu masih ada. Ya, jadi pada dasarnya kita mencari, oke, kalau misalkan kita input A, kita ganti X menjadi A, ya. Jadi kita dapat 0/0 atau tak hingga per tak hingga, maka kita bisa gunakan aturan L'Hopital ini, ya, sampai kita tidak menemukan bentuk ini lagi. Sampai kita tidak menemukan 0/0 atau tak hingga per tak hingga lagi. Seperti ini contohnya, ya. Di sini kita punya 0/0, ya, ini semuanya kita punya 0/0, maka kita pakai aturan L'Hopital. Kita lakukan terus sampai akhirnya kita dapat bentuk yang tidak 0/0 lagi di sini. Sehingga di sini kita dapat hasilnya. Cuman yang harus kita hati-hati adalah aturan L'Hopital itu cuma bisa dipakai ketika kita menemukan 0/0 atau tak hingga per tak hingga. Selain itu tidak boleh. Sehingga di contoh ini, ya, kita punya seperti ini masih 0/0. Kemudian kita pakai aturan L'Hopital, kita turunkan pembilangnya, ya, 1 min cos X kita turunkan menjadi sin X. Kemudian penyebutnya juga kita turunkan, X plus X kuadrat kita turunkan jadi 1 plus 2X. Tapi ketika kita substitusikan X sama dengan 0, dia menjadi 0/1. Nah, dia sudah bukan 0/0 lagi. Sehingga di sini kita langsung tentukan bahwa limitnya adalah 0. Kita tidak boleh lagi pakai aturan L'Hopital. Kemudian aturan L'Hopital juga bisa dipakai untuk limit satu sisi, ya, limit dari kanan atau kiri. Kemudian untuk tak hingga per tak hingga, ya. Untuk tak hingga per tak hingga ini kita bisa lihat terutama di contoh yang C, ya. Kita pakai aturan L'Hopital, ya, karena ketika kita masukkan E pangkat tak hingga adalah tak hingga kuadrat adalah tak hingga, sehingga kita punya tak hingga per tak hingga, kita turunkan masing-masing, ya. Turunan E pangkat X adalah E pangkat X, turunan X kuadrat adalah 2X. Kemudian kita substitusikan lagi, ternyata masih tak hingga per tak hingga, kita pakai aturan L'Hopital lagi. Sehingga turunan E pangkat X adalah E pangkat X, turunan 2X adalah 2. Di sini bentuknya sudah tak hingga per 2. Nah, karena sudah bukan tak hingga per tak hingga lagi, maka kita langsung tulis bahwa limitnya adalah tak hingga. Ya. Here is another example. Yeah. But before that, any question? Any question? No?
No, sir.
Well, now is it clearer? Is it more clear than before?
Yes, sir. It's more clearer than before.
Yeah. The rest of you, other than who was that? Was that Ray or Jason?
Me, sir. Me.
Ray, yeah. Other than Ray?
Saya mau nanya,
Ya.
untuk UTS nanti apakah nyampe ke materi ini?
UTS, yes.
Oh, okay.
Midterm, yes. Well, you can see, okay, let me open it, the syllabus. Yeah, so we will learn until wait. Okay, we will learn until a partial integration. Yeah. Jadi before midterm we learn partial integration. Yeah. Jadi sebelum UTS kita belajar sampai integral parsial. So in this case we will the midterm will include from the beginning, yeah, from week 1, yeah, from inequalities up to partial integration. But before the midterm, we will have our second quiz. The material will be from extreme values, yeah, from this morning up to partial integration. Yeah. Please don't be down.
Okay.
Sir, nanti ada kisi-kisinya apa dikasih
Apa?
kisi-kisi atau
No, there
Akbar?
you cannot expect something like that in your university year.
Okay, sir.
Yeah, well,
Keep spirit.
yeah. Well, maybe in the midterm there will be only about 10 questions, but you don't need to answer all of them, maybe, or I don't know. It depends on the coordinator of calculus, so I have to ask him first. Okay.
Okay, sir.
Yeah, well, this materials was not well. Let me talk about this later. But okay, now this is another trick. Yeah, if we find indeterminate form of infinity times 0, yeah, then how should we deal with this kind of form? Okay, for this first form, we can use our usual trick. In the answer A, we let h equal to, oh, sorry, this is not x to 0 from the right, but this should be h, ya. Di sini harusnya bukan x menuju 0 dari kanan, tapi h menuju 0 dari kanan. So, in this case, what we have is, okay, we change x into 1 over h, and 1 over x to be h. Jadi kita ubah x menjadi 1 per h dan 1 per x menjadi h. So in this case, we know that if x goes to infinity, then 1 over h is actually going to 0 from the right. Ya. Jadi ketika x menuju tak hingga, 1 per h itu, ketika x menuju tak hingga, h atau 1 per x itu menuju 0 dari kanan. Sehingga kita bisa menggunakan, so in this case we can use our old value, ya. Jadi kita bisa pakai yang sudah kita bahas sebelumnya. And then for the second one, this is a different trick. Let me write it here. For the second one, the trick is quite different. So what we do here, in this case, since if we directly substitute this value, we have 0 times minus infinity. So in this case, what we do is, okay, we want to apply Lupita's rule. So in that case, we can reshape or rewrite the equation in the quotient form, ya. Jadi karena kita mau memakai aturan L'Hopital, maka kita mengubah menjadi bentuk pembagian. So we have limit x to 0 from the right of ln x over 1 over square root of x, ya. Now we can apply, so now if we put this, in this case what we have is minus infinity over infinity. So in this case we can apply L'Hopital's rule. So we have limit x goes to 0 from the right. Derivative of ln x is 1 over x. Derivative of 1 over square root of x is minus 1 over 2x power minus 3 over 2. Like this. So from here we can rewrite everything. Yeah. So this is equal to limit x goes to 0 from the right of 1 over x times times minus 2 x power minus 3 over 2. Minus, no, not minus, it should be plus. It should be plus. So in this case, we will have this is equal to limit x goes to 0 from the right of minus 2 times square root of x. Then now we can substitute x here. So we have minus 2 times 0, which is equal to minus 2. Jadi di sini karena kita mau menggunakan aturan L'Hopital, maka kita ubah bentuknya sehingga di sini kita dapat bentuk tak hingga per tak hingga ya. Jadi akar x-nya kita buat jadi penyebut. Jadi 1 per akar x. Karena kita pindahkan ke penyebutnya. Kemudian kita turunkan 1 per 1 atas dan bawah. Atasnya jadi 1 per x, bawahnya jadi min 1 per 2 x pangkat 3 per 2. Kemudian kita tulis ulang ya. Jadi kita punya 1 per x kali min 2 kali x pangkat 3 per 2. Sehingga di sini kita punya limitnya menjadi limit dari min 2 akar x sehingga kita punya min 2 kali 0. Bukan min 2 ya, tapi 0, sorry. My mistake. Yeah. Any question? Is it clear?
Yes, sir.
Yeah. Now, if we find form infinity minus infinity, then we can rewrite them like this. Okay, in this case, somehow we have 0 over 0. Ya. Jadi di sini kalau kita masukkan langsung, ya 1 per sin 0 adalah 0, 1 per 0 infinity, kemudian 1 per 0 lagi infinity, ya. Sehingga di sini kita punya tak hingga minus tak hingga. Then we rewrite the limit, ya. Kemudian kita tulis ulang, kita samakan penyebut, ya. Then we have now if we substitute 0, we have infinity over infinity. 0 over 0, ya. Jadi kalau kita masukkan 0 di sini, sekarang kita punyanya 0 per 0. Since we have 0 over 0, then we can apply L'Hopital's rule. We take the derivative of numerator and the denominator. Ya, kita bisa lakukan, kita bisa terapkan aturan L'Hopital karena kita punya 0 per 0, ya, sehingga kita bisa hitung kemudian. Ya. So we see here that in this second line, we have 0, we still have 0 over 0 ya. Di baris kedua ini kita masih punya 0 per 0 ya. Then we apply again L'Hopital's rule ya. Kita apply lagi aturan L'Hopital. Then now we can compute it. We have 0 over 2 which is 0 ya. Now I want to show you some. Okay, so this challenge is easy, yeah. Yang ini mudah ya. The derivative this is not that hard. What I want is to show you this. Okay, maybe this challenge 4 and challenge 5. 4 and 5. Challenge 4. What do we have here? So if we substitute infinity, then we have infinity minus infinity, right? So in this case, we have infinity minus infinity. Then we rewrite the limit. We rewrite the limit so that it becomes now limit x goes to infinity of ln 2x over x plus 1. Yeah. So if we put infinity, still infinity over infinity, then in this case we put the limit inside ln. Yeah. From the limit rule, we have ln of limit x goes to infinity 2x over x plus 1. Then here we can apply Lupita's rule. We have ln of limit x goes to infinity of 2 over 1. Yeah. So here we have ln of 2. Yeah. Any question for this example? No?
No, sir.
Then we go to the next example. This is more tricky. For this case, the trick is different. Yeah. So what we do here is we make this equal to limit x goes to 1 from the right, e power ln of x power 1 over x minus 1. Or we can have limit x goes to 1 from the right, yeah, e power 1 over x minus 1 ln x. Or we can write it limit x go to 1 from the right, e power ln x over x minus 1. So in this case, we will have 0 over 0. Yeah. So in this case, we move the limit up there. So we have now e power limit x goes to 1 from the right of ln x over x minus 1. So in this case, we have e. We can apply Lupita's rule. Why? Because we have 0 over 0 here. 0 over 0. Then we apply Lupita's rule. We have limit x goes to 1 from the right of 1 over x over 1, which is e power 1, which is e. Yeah. A question for this example? Ada pertanyaan untuk contoh ini?
Sir, kenapa limitnya di ke atasnya?
Okay. Why I can move the limit to the power? Mengapa saya bisa pindahkan limitnya ke pangkatnya? Itu that is because of the limit rule. Karena aturan limit, kalian you can read it in the slide about limit. Kalian bisa baca di slide tentang limit. Pada dasarnya kalau kita punya limit dari fungsi, maka kita bisa masukkan limit ke dalamnya. Kalau limit dari fungsi komposisi, kita bisa pindahkan limit ke dalamnya. Sehingga di sini limitnya bisa kita pindahkan ke pangkatnya. Karena yang mau kita hitung limitnya adalah pangkatnya saja. Seperti itu. Ya. Is it clear?
Yes, sir. Clear.
Okay. This one is no, I think this one you can use the same trick. You can use the same trick as this guy. Okay, let me explain it in bahasa. Ya, di sini mengapa diubah jadi bentuk e pangkat len ini ya? Karena dengan seperti ini kita bisa mendapatkan bentuk pembagian. That is the only reason ya. Because we can only apply Lupita's rule if we have quotient form. Ya. Jadi kita cuma bisa apply aturan L'Hopital kalau kita punya pembagian. Ya. So for this one, I think you can do it by yourself. This one, yeah, this.
Berarti sir kalau misalkan jawabannya only E doang tuh berarti bisa?
Ya. Yeah. Because E is natural number, right? Karena E ini adalah bilangan natural ya, bilangan Euler.
Okay, sir.
This is the last trick. Evaluate this guy. So what do we need to do here? So for this one, what we do is, okay, limit x goes to 0 from the right, because here we have the form of 0 multiplied by infinity, multiplied by negative infinity. So in this case, what we do is we make it like this, ln x over 1 over x squared. So in this case now, what we have is negative infinity over infinity. So now we can apply L'Hopital's rule. We have limit x goes to 0 from the right of 1 over x divided by minus 2 over x cubed. So here we have limit x goes to 0 from the right of 1 over x. Ya?
Kelihatan.
No?
Nggak kelihatan. Iya, dah.
Sorry. So now we have 1 over x multiplied by minus x cubed over 2, yeah, which is equal to limit x goes to 0 from the right of minus x squared over 2, which is 0. Yeah. Yeah. Any question? No?
I think no, sir.
If not, then I think it's time to end this. Well, my plan was up to this slide, but it turns out that we can only finish this first part of class 9. So next week we will start from this applied optimization, just a little bit quick. Yeah, this is only consists of examples which you may need in chemical engineering later, and then after that we focus on integral. Yeah. So before I end this session, any question?
Oh yeah, sir. Maybe it's di luar pelajaran, but I want to know what the application that you used to make a graph like that.
This graph?
Yeah, about the graph you enter like so S fx, then it make its graph on itself.
Oh, this is a programming language called Julia. But I think in chemical engineering you will learn about MATLAB. I think, right? Is there any course that is related to MATLAB, like programming?
I don't know about MATLAB, but kakak tingkat pernah bilang katanya nanti bakal pakai MATLAB juga.
Yeah, then I suggest you to learn MATLAB. Don't try to follow me here, yeah, because I don't think any you can find any other lecturer in Universitas Pertamina at the moment that use Julia, other than me.
Okay, sir. Okay, I'm just curious.
Let me end the recording first, and then we can talk about this shortly. Okay.
Okay.